I'm going to go ahead and pass out the review. A couple more there just in case.
Okay.
Did I not put me here? I think this. See there anymore? Yeah. There's another one there just in case. So in addition to those problems, for some reason I forgot to put an evaluating function on that. So you can add this to the review. Oh, is there not? Is that extra? Usually there's just you two. Oh, there's someone there. Grab one off of there. There's an extra one there. Okay. Thank you. Okay, it's 9:30. How are y'all doing?
Tired.
Tired? I'm always tired on Monday. Wednesday, I'm like ready to go. You know? Okay, so we have a test on Monday, right? I told you I'd provide the review. So here's the review. And in addition to these problems, you need to also add this to the list. And then at the very end, it says, in addition to these problems, please be sure to review conversions. So what I recommend you do there is go back. Well, it's going to be way back here. There we go. I would just take a look at your homework for conversions. And not really, the scientific notation is not as big of a deal, but I do expect that you can convert, from metric to metric. And be real careful that you remember how to do conversions when you have squared units. Because I did that in class. I said you have to be careful. You have to write like meter, and then get it to, okay. So, and then you also need to be able to convert from imperial to metric, which would be something like, you know, inches to centimeters or inches squared to centimeters squared, or the other way around. All right, so make sure you review that. I will provide you a conversion table. So on the test, you will only have, or you will be provided with, where is it? This right here, okay? So you'll be provided with this, and I will also provide you with this. All right, so basically that page right there, well, I won't put the problems there, but that part right there down till right there, okay, will be given to you. All right, any questions on that? Okay, so what we need to do today is there's 2 more topics that are going to be on the test that we have not discussed. And so it's applications of linear functions. So last time we spent the entire class pretty much talking about the idea of a function, and linear functions are specifically lines that we had been studying but now written in functional notation. So we're going to solve the following application problems that involve linear functions. So the first problem says Mr. Thompson is on a diet. He currently weighs 260 pounds. He loses 4 pounds per month. Okay? So let me bring up something so I can write on it. So the first question is, write a linear model that represents Mr. Thompson's weight, W, after X months. So this, on the test, I'm not looking for just the answer. I mean, I want you to, you know, if it asks you for a linear function or a linear model, I want you to do that. I don't want you to just skip to part B and give me the numerical answer for part B. So y'all help me out here. I want to write a linear model that represents Mr. Thompson's weight, W, after X months. So remember, we have, from last class, the idea was that if we could write a function, right, where all we had over here were x's. And something linear would be something like, you know, if we had x plus 2y equals 8, I said in order to make this a function, we would solve for y, wouldn't we? Yes? Okay, so for us here, in this problem, we want to write a linear model that represents his weight after a certain number of months, x. So any ideas? What is Mr. Thompson's, tell me what's happening with Mr. Thompson's weight. It's going down by how much? 4 pounds every month, right? And what's his starting weight? 260, yes.
So I guess the way I write it would be 260 minus 4x.
Okay, 260 minus 4x is equal to what? His weight? His weight is 260 minus 4x, is that what you're saying? So let me write it this way. His weight, right, W, is 260 minus 4x. Now, why did you use minus 4x? What is this about? He's losing 4 pounds every month, right? And x is going to represent the number of months. So do y'all see that this is a good model for what's happening? Yes? Now, we're going to write it a little bit different now, just a little bit. I'm going to write this instead. Now, the only reason I did that is because I want to use functional notation. What we're saying is that his weight can be determined if somebody provides you x, which is the number of months, right? So his weight is a function of x. If you write it this way, it's kind of like writing it like this, where you have two variables, but we haven't expressed it as a function yet. So we will say weight, in parentheses x, right? Weight is a function of x, is equal to this. Now, I switched the order of these. Do you have any idea why I did that? I mean, this is correct, okay? This isn't wrong. But why did I decide to switch it like that? It looks like this now. It looks like our good old line, y equals mx plus b, doesn't it? This is the way we wrote lines before. So the m, the number in front of x, is always our slope of our line, and this number b is always our y-intercept. So if we were asked to graph this function, we could, couldn't we? So let me just review that. We haven't answered the second question. This is the answer to the first part, all right? But if I wanted to graph it, where would I start? So what would be the first point on my graph? 260, where? On the y-axis, I'd go up 260. So I'm going to put it right there. And then to get to another point, how do I get to another point on that line? So we look at this number. That's the same as -4/1. And that's our rise over run, right? So that means you go down 4 and to the right 1. Down 4, right 1, down 4. So we know that our slope is going to go, it's going to be down and over. So the slope of our line, right, negative slope would be like that. Oh, I totally missed it. Yes? So he's losing weight. As time goes on, the number of months, right? So x is the number of months. And this is his weight. Weight. Is that the way you spell weight? W-E-I. I thought it was I before E except after C. No? That's why I didn't like English. Okay? Because they give you these rules that didn't always apply, and to me that's not a rule. Okay, so if I were to be graphing this line, this is what it would look like, right? Now, technically, that part of the line doesn't exist because we wouldn't have negative time, like negative months. So this gives us a linear model, right? So let me ask you, what is wrong with this linear model? I mean, it kind of explains what's happening, right? Every month he loses 4 pounds, right? But why is it a model and not like exactly what's going to happen? Just look at it. What's wrong with using that line to represent Mr. Thompson's weight? Go ahead.
Can't really get to like 0 pounds.
Yeah, I mean, he'd be dead at some point, right? Like, what we're saying is that after a certain number of months, he would weigh 0. And I mean, that's just not going to happen, right? So it's a linear model. It's okay, but it's not perfect. It'd be better if we had a function that wasn't linear, that did something more like this, like came down and then kind of flattened out and like always stayed above some line. Would you agree? Like that's more realistic, don't you think? And so later on, we're going to study functions that do behave like this. And this is a good example of why we would prefer to use this model over a straight line model. Does that make sense? I'll show you something real quick. So I'm just going to have, y'all have used Excel, yes? So I'm just going to act like, I'm Mr. Thompson, and these are the months. Oops. Why is that? And here's his weight. He starts out at 260. So y'all see that after 1 month, he weighs 260. Or sorry, I should make that 0 months. That's when he starts. 0, 1, 2, 3, 4, 5, 6. Okay, so how much would he weigh after 1 month? It'd be that weight minus 4, right? And then that just keeps happening the whole way down, right? Following me? Okay. Now, what's nice about Excel? How many of you have used Excel and feel somewhat comfortable with it? Not many? Not many. Okay. So if I just highlight this, and I go to, where is it? This looks weird. Insert. Yeah, we'll just do that. I think this is as big as I'm going to be able to get it here. I'll just take that out of there. Okay, so that's basically what's happening with his weight, yes? Okay, so what's cool about Excel is that if you click on your data and you right-click, you can do this thing called add a trend line. And then over here, you can have the computer fit a function to your data. So if I wanted to do a linear function, right, then I could say add a linear, and then where's the display the equation on the chart. Okay, so that's it right there. And that is, this is the equation, right? Now it's a little bit off because it thinks we're starting at 1 when it should be starting at 0, but would you all agree this is a line, slope -4, right? Agree? Okay, but again, he's going to be dead at some point. So let's say that, you know, in the real world, he would measure his weight after each month. Maybe after the first month, it was like 256, and then it was 252. Then maybe it was 250, maybe 251. He went out and ate too much that month, and then, you know, 249. 249.5. So you see it's not a straight line anymore, right? So the computer is still trying to find a line that's a good representation of what's happening, so that you can actually, you know, still try and predict, like, so let's say after, you know, 10 months, here's where he is. He could use that line to predict where he would be in 6 months, right? He could say, okay, just, you know, I'll just use that equation, plug in 16, and that would be a prediction, wouldn't it? But you can also change it. I said, you know, it'd be better if we had something like, let's see, I think a logarithmic one would be good. And let's display the equation. Okay. I need to take the line one out of there. Sorry if I'm boring y'all to death there. I did the wrong one. Okay, so trend line, logarithmic, display the equation. There we go. Okay, so can y'all tell that this is not a straight line, the dotted one? Okay, and the computer still will give me the function, and this is a logarithmic function. We haven't talked about those yet. We will. But the whole point of this is that in the real world, you can have data. Like, data is something you'll have. And so in here we're working with functions, right? We're like, hey, if we have this function, this is, you know, how we graph them, this is how we graph a line, and we're going to spend the rest of the semester talking about graphing functions. But the big question is, where in the real world would you ever, like, get the function from, right? And this, I'm trying to show you that if you have data, a computer can generate what we call a best fit model and give you the function. And then once you have that, you can work with it. Does that make sense? Okay. All right, went off on a little tangent there. Let's get back to this. All right, so we know we have our function here, right? W of x was negative 4x plus 260, right? Okay, so that's our function, part A. Now part B, after how many months will Mr. Thompson reach his goal of 220 pounds? So how do I do this part? What are they asking for? How many months, right? So how many months means we are looking for the x, right? X is the number of months. So we're asking ourselves, what x will give us an output of 220? So this goes back again to last class. When I gave you a function, I could either ask you, remember the two questions we were doing? were like, this is at the end of class, I would either ask you, hey, what happens if you plug 2 into the function, right? What do you get out? Or I could ask you this question, which is a completely different question. Sorry. This one says plug 2 into the function, see what comes out. This one says, what do you plug into the function to get 2 to come out, right? Totally different questions. So when we look at part B, we have our function. Which of these two is it? Are they asking us to plug in 220 into the function? Or are they asking us to figure out when our function is 220? When our function is 220 is what we're asking for, right? So I come over here to my function, I ask myself, when is this 220? So I write down negative 4x plus 260. I say, when is that equal to 220? This is the question, right? And now all you have to do with that is solve for x. So you have a nice little linear equation in one variable. So solve for x. So we would do what to solve for x here? Subtract 260. All right, cancel here. Over here, what would we get on the right side? Negative 40. And then finally, we would divide both sides by negative 4. And x would be 10. So our answer is what? 10 months. All right, we want to make sure we put that on there, months. All right. So look, I want you to be careful because some of you may have been able to just say, okay, look, he starts out at 260, right? He goes to 220, that's 40 pounds, right? He's losing 4 pounds per month. It's 10 months and you don't do any math. Do you agree you can maybe do that mentally? Okay, on your test, I might ask you something like this. Same question here. I might ask you, how long does it take for him to reach not 220, but something like, 177.4? See, then it may not be as easy to do mentally. Does that make sense? So you need to be able to set up the equation. The only difference between that one and the previous one and this one would be the other side is 177.4, right? And so you have to go through the actual algebra to solve it. I don't think it's something you can do mentally. Understand? Okay. All right, let's look at the next word problem. We're going to skip 2. I'm not quite sure why 2 is even in this thing, so we're skipping it. Don't even worry about it. All right, Kara uses the linear model 20,000 plus 0.3x. I'll go ahead and jot that down. To predict her total salary from achieving total sales. I have to move this over. There we go. Of achieving total sales of X. Interpret the slope and Y-intercept in terms of her salary and sales. So all this is asking you to do is talk about what these numbers are. Okay? Talk about the slope, talk about the Y-intercept. So let's talk about we'll do the Y-intercept first, this number here. What is that number in terms of her salary and stuff like that? What is that number? What is it? It's part of her salary. Would you all agree?
It's her base pay.
Her base pay. Okay, that's what I was looking for. That's the money that she's going to make regardless of her sales. So as long as she shows up to work, according to the model, she's going to make $20,000 no matter what, right? Even if she sells nothing. So this is what we would consider her base pay. Now it doesn't say if this is yearly, does it? No, it doesn't. So we don't know if that's $20,000 a year or $20,000 a month. I doubt it's $20,000 a month, but okay, that's her base pay. Okay, so the Y-intercept is her base pay. All right, and then what is the slope representative of? So the 0.3, not the x. The x is her sales, right? The x is her sales, but what's that 0.3 mean? it's like a commission, okay? So that's how much she's going to make for whatever she sells. So if she sells nothing, she gets nothing. If she sells, I don't know, what if she sells $100 worth of stuff? How much is she going to get? .3 times 100, right? Which would turn out to be 30. So I'm looking for somebody to interpret that number a certain way. Yes, it is commission, but what commission is she making? I don't want to give it away. 0.3. What's that? 0.3. If I tell you you're going to make 0.3 of your sales compared to 0.5 of your sales, what would you prefer to have? 0.5. 0.5 would represent 50%, right, of your sales. This represents 30% of her sales. So this means, this slope means she has a 30% commission. Help me out, I didn't take English. Just ION, it's not double S? It is double S? Who cares? All right, commission, right? 30% commission. Right? So this is just asking us to look at the linear equation, the linear model, read the problem, it's talking about her salary and her sales, and to interpret what these numbers mean. If you look back at Mr. Thompson in the previous problem, right? $260 represented what? Wasn't his base pay, right? It was his starting weight, right? And the -4 represented his rate of change in his weight, right? That was how much his weight's changing by. So the point is just that with every linear model, this number and this number have different meanings. That's all right? Okay. All right, tuition at college XYZ is $80 per credit hour with an additional $55 student fee. So part A, what is the one-time charge or fixed cost? What's that? The $55. So this is the way it works at most colleges, right? You have to pay a certain fixed fee, no matter what. You're going to pay that if you take one class or you take 5 classes. We have a fixed cost, and then you pay like per class, right? And they measure that on the credit hours. How many credit hours is this class? 3, right? This is 13, 14? That second number is always the credit hour, right? So you may or may not know that, but that second number is always the credits. Do you know what the first number is? Yeah, this is basically the level, the year level. So college is basically a full degree would be 4 years. So when you're like by the time you're a senior in college, you're taking 4,000 level courses. The starting number is going to start with a 4. Okay, and then these numbers just don't worry about those. Okay, so the one-time fixed cost here is the $55, right? Okay. What is the variable cost? What is the thing that's going to depend on the number of hours that's taken? So what's variable in this? Well, the 55 doesn't change, right? The only other thing that's going to change is impacted by this $80 per credit hour, right? So what is his variable cost? Does it say his? It says his, right?
No. Oh.
Who are they talking about? Okay. So what's the variable cost? This is the $80 per credit hour. That's going to depend, right, on the number of hours the student takes. So that's variable. It changes. All right, so write the tuition function, capital T of x. So what is x going to represent for us? The number of credit hours the student's going to take. All right? So we said no matter what, the student's going to pay $55, right? But then added on to that, they're going to pay $80 per credit hour. So I'm going to put what? 80x. And just to stress here, x is the number of credit hours. And of course, capital T is going to be the tuition, right? That's your total tuition cost. So this side of the equation is going to spit out how much you're going to spend to go to school that semester. All right, so part D, let's get some sticks involved here. Damien? Is Damien here? Seems like I haven't said these in a while. Yitzel? Say it right? All right. All right, so look at part D. Can you read it from where you are?
Yeah.
Okay. How much will it cost to take 9 hours? Can you tell me what is it that we are replacing? Because remember with functions, I'm either telling you to plug something in for x, or I'm asking you to see what x spits out a certain number. So are we going to be plugging in 9 or figuring out when this is equal to 9 for part D? Pardon? Plug it in, right? Because 9 hours means 9 credit hours, right? And that's x. So I could say T of 9, right? That would be appropriate notation. I'm replacing x with 9. Plug 9 in. And we multiply first, right? 80 times 9. 80 times 9 is 720. And we add 55 to that, so what's that going to be? 775?
Yes.
Okay. Itzel? 775 what? I mean, that is the correct numerical answer, but what is that answer? 775 what? Dollars, right? Because the tuition, this is what comes out, right? We plugged in the hours, it spits out the money. So $775 for that semester. So you have to put the unit on there, all right? Make sure you put the unit. Okay, Caroline? Caroline, part E, how are we going to do that? Part E? Can you read it from where you are? Okay.
Do you divide 1095 by 80? And then subtract 55?
Okay, all right, so yes and no. What you're saying is that this is our tuition, right? And we want to know how many hours. So we're not taking that number and plugging in for x now, right? We're not going to plug 1095 into here. Instead, we're going to see when is this equal to that, right? So I think what we want to do is write out this equation. We want to say when is 55 plus 80x equal to 1095? Y'all see the difference? This is the main concept here, is that when you have a linear function, or any function, you're either going to be asked to plug something in, or you're going to be asked to set it equal to something. And in this case, we're setting it equal to this. Now, you had said divide by 80, right? And I said yes and no. After subtracting the 55. Okay, so we have to first subtract 55 here. That'll get rid of our fixed cost part. We'll have 80x equals, and then over here, what do we get? 1040? And now we divide both sides by 80.
Which is
13?
13.
Okay, so 13 what, Caroline?
Credit hours?
Credit hours. So this student took 13 credit hours. Their tuition was $10.95, and we were able to go backwards and figure out how many credit hours. Okay? All right, now, we're done with this problem, but I want to talk about something. It's definitely off topic but on topic, and I don't want you all to think that I'm always going off topic, but how many of y'all know how to compute your GPA? How many would like to know how to compute your GPA? Anyone care? All right. I think it's important to know how to do it. Because a lot of you, the programs you're going to go into that are very competitive. How many, are there nursing in here? No. Nursing, right? Things like that. Very competitive. You want to have a high GPA. So the way it works is this. Let's say that you take a couple of classes. I'm going to put them up here. I'm just going to make them up. Maybe you take this class 13, 14. Anyone want to share another class they're taking right now? Anyone taking something that's not 3 credit hours? What is it? 2402? What is that class? Anatomy. Okay. Anything else? Anyone taking something like, it's not PE, but it's, what is it? No? No one's doing like working out? No? Over there? There's classes where you can like work out, no? No one's taking anything like that? You are?
I just don't know the number.
You don't know the number?
It's 1 credit.
It's 1 credit? Okay, let's just make up a number then. 2106. Okay, 16. 2116, I don't know. All right? 1 credit hour. And then let's say you're taking another class. Let's make it 2301. Okay? So let's say you're taking these 4 classes this semester. All right? Yes? How do you compute your GPA? Y'all remember like I'm pretty laid back. Would y'all agree I'm pretty laid back? Okay, I have one policy, and it's being on your phone, right? Okay, it's been a couple of days now, so no more, because the penalty in the syllabus is what? Do y'all remember? Anyone remember the penalty in the syllabus? What is it? 10 points off your exam, you're asked to leave counted absent. Okay, so I don't want to get to that, but you know, it's just kind of a respect thing, all right? All right, so got these classes. Let's say we get some grades. Okay, so you tell me, what grade do you want here? Okay, so a B. Okay, you got a B here. How about that one? Anatomy, you can get an A in there? You want an A. Let's say you got an A, okay. All right, and then let's say that this athletic class that you're in, you just total slacker, okay? Total slacker, all right? And then let's say here you've got a C, all right? Yes? So obviously that D is going to not be good, but okay, let's do this. So the way this works is as follows. What you're going to do is you're going to take, you have a scale first. An A is always worth 4, a B is always worth 3, a C is always worth 2, a D is worth 1, and an F is worth nothing. It's like you were never there. Okay, so what you'll do is you'll take your grade, convert it to its number, right? So 3, 4, what? 1 and 2. Okay, then what you're going to do is you're going to multiply that by the credit hours, okay? So I'm going to take 3 and multiply it by 3. I'm going to take 4 and multiply it by 4. And then I'm going to take 1 and multiply it by 1. And then I'm going to take 2 and multiply it by 3. Understand? So this is your credit hours. And this is your grade, right? But as a number. And now you multiply these. Let's see, what do we got? 9, 16, 1, 6, okay? Now let's add these up. So you add, what's that, 25, 26, 32, yes? 32. You with me? Okay, now what you're going to do, last step, is you're going to take this number and divide it by the total number of hours you took that semester. So how many hours did we take? 7, 8, wait, 7, 8, plus 3, right? 11? We took 11 hours. So we're going to take this and divide it by 11. Someone on their calculator, please. Total hours. And this is going to be your total earned. I'll just say total earned. So what is that? It's going to be a decimal. Approximately what? 2.9. 2.9. So your GPA for that semester is 2.9. Now 2.9, where's that? Well, that means you're C student, almost a B student. Yes? That's what that means. So these nursing programs, anyone know what like minimum GPA is to get in? Some of them? What? 3.5, right? So this was a okay semester, I guess, but not, I mean, it's not helping you get into nursing school. Okay, so let's just keep this up here. Let's say this happened instead. What if this student, same scenario, same classes, got their B, okay? But let's say that in the anatomy class, that's where they did bad, and then they got A's everywhere else, right? So B, but here got a D, that was an A, and that was an A. Let's see how that, you know, if it changes things. Or should I do it this way? Why don't we make this one, you know what, let's make this one a C. That way the only thing that happened is these two changed, right? And you may think, okay, I get the same grades, A, B, C, D, I'm going to have the same GPA. No, it's not. So here's why. This is first converted to its number. That's a 3. That's a what? A D is a 1, right? A is a 4, and C is a 2, right? Then you multiply these by the credit hours. So this was a 3-hour class, this was a 4-hour class, this was a 1-hour class, and that last one was a 3. Multiply them, you get 9, 4, 4, and 6. You add them up, and what do you have? 23? You'll get 23 there? You take 23 and you divide it by the number of hours, but it's the same number of hours, right? And what's that? Someone do that. 2.09. 2.1-ish, okay? Look at that. Why is it such a big difference? Because you got a low score, right? You got a low grade in the class that had the most credits, all right? So you can't fix your GPA by taking a bunch of basket weaving classes or, you know what I'm saying? You can't do a bunch of classes that are just 1 credit and expect to boost your GPA. You have to take credits, a course that has a lot of credits and do well. But if you mess up one of those, it has a dramatic impact on your GPA. And so to figure out your cumulative GPA, you just do this, you take all your semesters that you have together and just do the same process. Understand? Okay, now there is one question on this. What happens if this, let's say this student took this, did this, got that D won't transfer anyway. No institution's going to take a D. They only take C's and up. So what happens if you retake the class and get an A? What happens? Well, the reason I'm asking is because it depends. Like here at this college, if you retake that D will go away and it will never be part of your GPA again. Okay, it's like you never took it and it's replaced with an A. But if you transfer to another university, they may, it depends on where you go, they may say, no, we're going to count them both. And so they kind of average together. And so that D will still follow you and still hurt you. So it may not hurt you here, your GPA here might be high, but your transferring GPA might be different. So you always want to know, if you're going to transfer out to another school, how they calculate that GPA. And the big thing is don't get a D, all right? And also, what is a W?
Withdraw.
Okay, a W is a withdraw. Now, is it better to get a D or a W? What do you think?
Withdrawal doesn't count against your GPA.
Yeah, that's right. A W won't hurt your GPA, but they track them. And in Texas, you're only allowed to have 6 W's. And after you have 6 W's, you have to start paying out-of-state tuition. Do you all know what that is? It just means you're probably not going to be able to afford to go to school. So, and it's basically, let's say that I'm from a different state and I want to come to this college. The reason I have to pay a lot more is because I'm from a different state, I'm not paying taxes, county taxes. And that's where a lot of the money for schools comes from, taxes. So if you're not paying for taxes in that location, then you're going to pay more for the school. All right. I'd hope that that's somewhat useful as you're trying to figure out what's going on with you. It's not that hard to do once you know what to do. It's just a little bit of multiplication, division. I think it looks like craziness when you see it. You're like, what the heck? All right, let's get back to our word problems. All right, this next one always kind of throws people. It's just the wording of things. We have to be kind of careful with this. So this guy Joe, right? He's got this part-time job being a dog walker, I guess. Yes, this is a real thing nowadays. He estimates that his annual insurance etc., is $420. On average, he spends $4.50 on gasoline per visit. He charges $15 per visit. Note that this is an annual cost function. Okay. So you got to make sure you understand what's going on here. He goes and walks dogs or cares for, I don't know, plays with them. And every time he goes, he estimates he's going to pay $4.50 every time he goes in gas. But he's going to earn $15 every time he goes and does a job. So we're, first of all, looking for what is the one-time fixed cost for Joe and his little side job here. Tiana? Wait. Tiana, I said that right? Tiani, sorry. I said it's an I don't know, my fault. Yeah. Tiani.
Would it be 15?
His fixed cost. So do you understand the question? I mean, like, do you understand the wording?
It's saying like what's the price that he's gonna pay, like that's gonna stay the same? Or what?
Let's read it. Let's not read it, but what is this? Let me ask you what this is. Do you understand? He estimates his annual insurance to be, do you know what this 420 is?
What's his annual insurance, like what's gonna be at the end of the year?
But what is that? I mean, like annual insurance, what are we talking about here? Like, what do you think that is? Like, why does he need insurance?
Like in case he gets hurt or something?
In case he gets hurt or in case he accidentally lets go of the dog and gets hit by a car and then he gets sued, right? I mean, like at least he understands that, like, he better have some insurance in case something goes wrong, right? And he's gonna have to pay that out of his own pocket every year, right?
Oh. Okay.
Right? You see, so that cost right there, that's fixed. No matter what, like, he's gonna pay for that insurance, and if he doesn't do a single dog job that whole year, he just lost that money, right? So that is going to be a fixed cost. Agreed? Now, let's put that here. All right, so okay, Kiana. I said that button down. That I got right. Were you the one asking me about that line thing? I found it. Yes. Yeah, I did find it. I just haven't put it in yet. I don't know, just like magically it was on my desk today. I don't know. Okay, what is his variable cost? So it says variable cost. Okay, so are you debating between 15 and 450?
Yeah.
Okay, which of those is a cost? When you think cost, do you think money going out or money coming in?
The
going out. So which one of those is going out? 450. Does everyone agree? He has a variable cost of $4.50 per visit, right? All right. Sir, what was your name? What was your name? Ryan?
Ryan?
Yes.
Alex?
Alex. So I'm going to try and help because you look like you're a little out of it today.
Yeah, a little bit tired. I didn't take my.
Okay. Okay, so I was just going to try and get you involved here a little bit, might help out. So the cost function here, the last one, let's go through and see if we can't create the cost function. Now the x here, can you all help out? What's x going to represent for us here?
The X is going to be the amount of visits that's going to be.
Number of visits. Okay, so as long as you're aware of that, I'm going to write C of x down where x is going to be the number of visits or number of jobs he does per year. Yes? Okay.
It's going to pretty much be 420 plus, then it's going to be an X on the outside, or then a parentheses, then it's going to be 450 plus 15. I don't know, wait, I'm thinking that wrong, sorry.
Yeah, this is what makes this one a little bit tricky.
Okay.
We're talking about cost, right? We're talking about the money going out. The money going out.
So it'd be X.
Let me put the 420. You said 420, right? Like no matter what, he's got 420 going out for his insurance, right? Now, in addition to that, he's going to have how much every job he does?
$15 every time.
That's the money coming in,
Oh, yeah,
right? The money going out,
that's going to be
the 450. Agree? So,
So we got to subtract the 15 by the 450, so that way, is that per, would we do that first? Because that's both per visit.
yeah, well, I think the reason why this is confusing, and I told you it would be to begin with, is what is the use of the 15 in the problem?
That's the income versus the 450 is the outgoing.
That's right. So when we're asked to come up with a cost function, is the 15 even going to factor in? It's not. Okay? Because all they want to know is how much cost there is here. All right? So this is going to be 450x. Do y'all agree that's how much it's going to cost him? This question says nothing about the money coming in. It only talks about the money going out. So you have to understand what the word cost means. All right? So that is his cost function right there. Agreed? If he does 0 jobs, how much is he going to pay out? If he does 0 jobs, 420, right? If he does 1 job, it's going to be 420 plus 450. 2 jobs, 420 plus 420 times 2, right? Okay, now I believe is there anything else? Yeah, that's it, right? That would be the answer, and that would be it. Now, just, because we're talking about cost, now let me ask you this. I'm going to ask you a different question. What is the revenue function? I'm doing this example because I know not everyone in here understands the difference between these. The terminology, cost versus revenue versus profit. Okay, these all mean different things. So that's why I'm doing this example, so that if you get a question like this on the test, you understand like what I'm talking about. So what is revenue? Cost is what goes out. Revenue is what comes in, right? What comes in. So like, first thing came to my mind is like Chick-fil-A. I don't know why. Okay? So Chick-fil-A, every day they sell, a couple of nuggets, right? So they bring all this money in, right? That right there is the revenue. The cost is they had to pay their employees, right? They had to have the electricity on. They had all these different things, right? That's the cost. Profit is what then?
Profit is after paying for all that residual stuff, how much money
Was left, right? So I'm going to write that down in a second, but I just want to make sure we understand difference in the terminology. Cost is the out, revenue is the in, profit is the difference. So we'll put that up in a second. So right now, what is the revenue function? So Kristen, you're up. So what is our revenue function? What's the thing that's going to tell us how much money is coming in? I'm going to do our best.
Jumping the gun on this, but I want to write 420 plus 4.5 times x minus 15x.
You a little jumping the gun. You are talking about profit. Okay, so revenue is just the in. So how much is he going to make? How much is he going to bring in? That function
$15
per visit, right? So 15x, that's it, right? So you can see here that if x is 0, right? If x is 0, he's going to have to spend 420 and he's going to make nothing, right? He's going to bring in nothing. But if he does, let's say, 5 jobs, right? He's going to pay 420 plus 450 times 5, so he will have paid a lot of money, right? Cost. But he's also going to bring in 15 times 5. See the difference? Okay, now, the last question. What is the profit function? So the profit, and I'll put it up here, profit is always, P is always revenue minus cost. Whatever your revenue is, whatever you bring in, subtract the cost, and that will be your profit. So, Frank? No Frank. Evan? Okay, Evan, we have a cost function, we have a revenue function asking for the profit function. So I'll write it right here. What do you got? I'm going to call it P of X. So our profit function should be revenue, right? So what's our revenue function? 15x, so I'm going to write 15x. And then I'm going to subtract from that, right? Subtract from that the cost function. So subtract this, yes? So be careful here when you subtract it. Evan, I'm putting it in parentheses. Why am I putting in parentheses, Evan? Why am I putting parentheses here and then all this stuff? And not just, why did I not do that? Yeah, you have to subtract the whole cost, right? If you just do a minus here, it's just going to subtract that first piece, and then it's going to add this. It's going to look like he's making $15 and an additional $4.50, but that's not what's happening. He's making $15 per visit, but he's taking away his fixed cost, and he's taking away the gas money. And now we can distribute through 15x minus 420 minus 450 x, right? Distribute the negative through. And now we can combine these like terms. So what's 15x's take away 450x? What is that, 10.5? So this is it. This is his profit function right there. Is it a line? It's a line, right? This is a line. There's a slope of 10.5 and it has a y-intercept of 420, right? Okay, now I could ask you a couple of questions about this, couldn't I? Couldn't I say like, here's a good one. How many jobs does he have to do to break even? What do I mean by break even? What's that? Yeah, so basically, how many jobs does Joe have to do in order to not lose money, to just